I will show you how to go through the process of solving for x or y or z or whatever letter they put in there on very simple linear equations. Now make sure you pay attention to the notes there, those 5 rules, and I'll go through those as I go through the examples. So let's look at the first example. 3x minus 3 equals 7 plus x. Now I want you to hear this. This is a little different from what you've probably been taught. Some of you know some of these rules about moving things to the other side and changing a sign and all that. I want to show you a different way that will work in all problems where you're dealing with letters or numbers or whatever. And that is this. To move anything across the equal sign, you do the opposite operation. To move anything across the equal sign, you do the opposite operation. How is the 3 connected on this side? It's subtracted. Therefore, you add 3 to both sides. And so you have 3x, that adds up to 0. You have 10, and you have plus x. Now, another rule, we need to get all the x's on one side. Doesn't make any difference whether we get them on the left side or the right side. We need to get all the x's on one side and everything else on the other side of the equal sign. So we need to move this. How is it connected? It's added, therefore we subtract it from both sides. So what we have is 2x is equal to 10. Now watch, listen as I explain all these in terms of doing the opposite operation. Now, we must get the x by itself. So how's the 2 connected to the x? It's multiplied. Therefore, we divide it. And so we have x is equal to 5. Now again, you may already know how to do this, but if you're first learning, or I would advise you to learn it this way. Learn to move things to the other side by the opposite operation. All right, now, once you get an answer, you should always check that answer to see if it works. So the original problem was 3 times x, well, x is 5, minus 3 is equal to 7 plus x. X is 5. This is 15 minus 3 is equal to 12, and so it does check. So we did it correctly. All right, let's go to the next example. I'm going to say a lot of things in these few examples that I have to work with that are extremely important for you when you go into college algebra and other math courses, if you have to do that. That is, we're going to move things across the equal sign by doing the opposite operation. All right, first of all, we must get all the x's on one side and the numbers on the other side. So if we want to do that, we can do it this way. How is the 4x connected? It's added, therefore we subtract it from both sides. Now, there's a law that says whatever you do one side of the equation, you must do the other side the same. All right, now adding here, this is 10, these drop out, and this is a minus 1x. Now that's a minus 1, therefore I divide by minus 1 by minus 1. And so I get x is equal to positive x because a minus and a minus is positive in division. And here I have 10 and a minus 1, which is a minus 10. Okay. So let's check that. Problem was 10 plus 4 times x, x is a minus 10, equals to 3 times x, which is a minus 10. So we have 10 minus 40 is equal to minus 30, and sure enough, that checks. Now let's go back and look at this one again. I want you to hear all these sentences now, and that is this one. It doesn't make any difference which side that your x has to be on. You can move the x to either side. And I want to rework this problem now by doing the x's to the left side. Now, if I have just the 3x here by itself, to move it, that's a plus. So I'm going to make a minus 3x to both sides. And at the same time, I'm going to move that side. That's a positive, so I'm going to do the opposite operation. Now, adding, this drops out. Here we have x. This drops out. We have a minus 10. Same answer as we got a while ago. Now, with practice, you can do both of these at the same time, moving both of these at the same time. If you'll look at later, after you finish the tape, if you'll look at a lot of the examples in the back of the notes, you'll see this being done, both of them in the same step. There are a lot of examples back there for you to study and pick up and learn how to do this. All right, let's go to the next example. The next example is the concept that we have some parentheses in the problem, so we need to get rid of those parentheses. So here we have x and a minus, that's a minus 1. Minus 1 times a minus 2 is a plus 2. All right, how is the 2 connected? It's added, therefore we subtract it. Okay, so we have that. And again, listen to moving it across. I know you may think, well, I'll just move it over and change the sign. That's not going to work later on to a more difficult problem. So learn the concept, that is, to move anything across the equal sign, you do the opposite operation to both sides. All right, then again, don't forget to check it. It's x, which is 1, minus a minus 2 is equal to 3. And sure enough, 1 minus times a minus is a positive, and it does check. All right, let's go to the next example. And here's a good example of using the rule that I want you to learn. That is opposite operation. So let's do this one. How is the 3 connected? Now let me rewrite this problem another way it could be written. You can place that x on top, or you can put it out here. Okay, that's the same meaning. All right, now how's the 3 connected to both sides? It's divided. Therefore, I multiply this side by 3 and this side by 3. Those divide out, and we have a minus 2x, and over here we have 15. Now, how is the minus 2 connected to the x? It's multiplied. Therefore, we divide both sides. And so we have x is a positive, minus and a minus. And over here we have negative 15 halves. Now, your teacher may want you to write that as a minus 7.5. That answer right there is sufficient. Okay? In fact, it's a better way of writing the answer, especially if we want to check it. Now, if we want to check it, we have a minus 2/3 times x, which is a minus 15 halves. And that's supposed to equal 5. Well, it is. 2's will divide out, and 3 will go into 15 5 times, and a minus 1 times a minus 5 is 5. So it checks. Do the opposite operation, okay? All right, let's take the next example. Now, the next example, here's another rule. And that is this. if you have a linear equation, linear equation is an equation into the first power. If you have a linear equation that has fractions, that has denominators, okay, then the first step is to multiply everything there by the common denominator. Okay, don't be moving things across and doing opposite operations if you have fractions in linear equations. Multiply everything by a common denominator. So a common denominator here is 4. So what I'm going to do is come up here and multiply this by 4, this by 4, and this by 4. And that's a mistake a lot of people make with carelessness. Don't forget you must multiply everything, everything, everything. All right, so what happens? The 4's drop out, we have 3x. 4's divide out, we have 5x. And 4 times 2 is 8. All right. So now we go back to what we've been doing in the first 3 examples, is getting x's by themselves and everything else on the other side. So let's move the 3x across. We'll subtract it. And let's move the 8 across. We'll do the opposite operation. And that drops out, and that adds up to 2x. And that drops out, and that adds up to 8. Now, one of your other tapes on this series, and also in your textbook that you're going to do inequalities, where you have a less than or greater sign in here. And you'll be a lot better off, a lot safer working if you'll always move these x's where this is a positive. Because when you come in and start dividing by minuses, it changes that in inequalities. Okay, so my suggestion is always move things so that you'll have a positive x. All right, how's the 2 connected to the x? It's multiplied, therefore we divide. And so we get x is equal to minus 4. All right, if you'll just do this way, you'll find out as you go through algebra that it'll be a lot better off than trying to memorize some of the other ways that you've been taught. Okay, so let's go check that answer. So we have 3/4 x, and x is a minus 4, equals 5/4 x, x is a minus 4, plus 2. And what happens? We get a minus 3. What happens? We get a minus 3. Checks. All right, now let's go to the next example. Now I'm trying to go slow and easy on this, and if you don't follow this thing, or after you work a few examples at the end of this tape, and you're not sure about it, go back, rewind the tape, go back over it. Go back over it again and again until you understand what's going on and you get the sentences down. All right, here's the next sentence. If you have a linear equation with parentheses, the first thing is to remove the parentheses. So therefore this is a minus 8, and a minus times a plus 3 is a minus 3m, and a minus 1 times a minus 10 is a plus 10 is equal to 11. So, remove parentheses is this one. Now another one this has is this, combine terms on both sides when you can, before you start moving things across. Again, right here, we have a minus 8 and a plus 10, so that's 2 minus 3m is equal to 11. Right. So if you have a bunch of m's or you have a bunch of numbers, get those combined, and over here, combine these, then start moving things across the equal sign. All right, now I'll work this one 2 different ways. Let's go ahead. We've already got the m over here, so let's move the 2. How's the 2 connected? It's addition, therefore I'll subtract it. and that drops out, and that's equal to 9. All right, how's this connected? Multiplication, therefore I'll divide by minus 3. And so that's equal to 1m, and that's a minus. Plus divided by minus is a minus 3. Okay. Now, let's go back and look at this at this point a different way. A while ago I said that it's best to move the letters and make them positive. So I'm going to move this across to the other side. And I'm going to move this across to that side. Okay, so that's a minus 11 and a minus 11. Now when I add, I get a minus 9. That drops out. That drops out. And I have 3m. Now, how's the m connected? Multiplication, therefore a divide. And you get the same answer. All right, now let's look at the last example. Okay, now we're looking at a very complicated, has all the rules in here except the denominator rule. But we have parentheses and we have combining terms and that. So let's look at it. First rule, remove parentheses. So 4 times 5z is 20z. And I put a mark through these so it doesn't look like a 2. 4 times 2 is 8. And then plus 1. Then over here we have minus 2 times this is a minus 2. Minus 2z plus 16. Okay, now what we have is combine all the terms. Combine all the terms. Combine all the terms. So 20z, and here I have a minus 7, adding those, and then adding the numbers here I have 14 and 2z. Alright, now we're ready. Moving things across. So I'm going to move the 2z across. Subtraction, therefore add it. The 7 is subtracted, therefore add it. And adding here I get 22z, and over here I get 21. These drop out, these drop out. Now, how is this connected? Multiplication, therefore divide it. This divides out to be a 1z, and this comes out to be 21 over 22. Now, this is why that you need to learn to move things by opposite operation. Too many people would look at something like this and think about just moving the 22 over and subtracting and get a 1. But if you keep it in mind of what you're doing, then it will be the safest way to work the problem. All right, let me show you another example right now of how all this works with letters. So let me give you a problem like this. Let's say we have A plus B times X over C is equal to D, okay, plus E or something. All right. Now, we're trying to solve for X, so we got to move it. How's this connected? So it's subtraction, so I'll move it across. So I have left B X over C is equal to D plus E minus A. You don't get to combine things, you just move them across. Now how's the C connected? It's divided, therefore you multiply. And then how's the B connected? It's multiplied, therefore you divide. And you can take complicated looking problems that have letters, not just numbers, and you can move things across by doing the opposite operation. Okay, now what you need to do is to work the example problems on the notes and also look at all the other examples and talk through them using the rules that I've been trying to explain. Watch the problem as you look the ones already worked out for you, that look at it as moving the thing across the equal sign by using the opposite operation.